We are going to do past paper questions or some topical questions of oscillations, right? So this question is related to finding max and minimum, uh, the force, acceleration, or the speed, right? So this question is related to max and mins. The question is about having this system where the spring is attached. And here the spring is attached with the mass, right? Having mass m. And here we can say the distance. This is your equilibrium point or mean position. This is going to be your equilibrium point, or we call it mean position. Now the force is acting on the left hand side. Let's say the force is acting in the question, it says that force is acting on the left hand side. That means the object is being pulled. So right now the speed is going to be 0 at if it is at rest, right?
Yes, sir.
So if it is at maximum displacement, if it is at maximum x equal to maximum at this point, right now, if it is maximum at this point, so this means the force that is exerting is also maximum, right? So the
Yes, sir.
force is going to be maximum because the spring is, is at maximum point. Hello, Assalamu alaikum. Hello, Assalamu alaikum. I'll call you back. Okay, Allah Hafiz. So since it is at maximum point, so this is the maximum force. Maximum force is exerting because we are unable to stretch it more, right? Because
Yes, sir.
the spring is no more stretched, right?
Yes, sir.
And what if I say we start pulling the spring is pulling the object back. If the spring is pulling the object back, okay, very
Yeah.
strongly.
Sir, by the way, I have my physics midterms a project to do.
All right. When do we have to submit?
Um, I think we'll start doing this presentation by Monday. I'll send you the topics because I need to research about them and I need a bit of help.
Right, okay. So you have to submit the portfolio?
Yeah, by the end of the week, I think, since we don't have physical midterms.
Yeah, yeah, I know. Okay, so inshallah we'll discuss it in tomorrow's class, or you're gonna send me on Monday, I think.
Yeah, I'll try to get
If you can get it, so if you can send me as soon as possible, so we can, start working on it.
Um, okay, sure.
Okay, so this, if the spring is pulling the object very strongly, the acceleration is going to be, the maximum as well. The acceleration is also going to be maximum since acceleration is directly proportional to the force, right?
Yes, sir.
So the moment, the moment, the moment, the moment the object is stopped at the maximum point, at the maximum point, the velocity is zero, right? The velocity is zero. So what about the kinetic energy? Then kinetic energy would also be zero, because what we know that kinetic energy is actually half mv squared, right? Therefore, if the v is zero, the kinetic energy would also be zero. Okay.
Okay, sir.
So which energy will be maximum at this point if the kinetic energy is zero?
Sorry, can you repeat your question, sir?
I'm saying which energy is going to be maximum if the speed is zero, if the kinetic energy is zero. So which energy should be maximum? Yes.
Potential energy?
Yeah, potential energy. Okay. So the potential energy will be maximum, okay, at the maximum distance. Clear?
Yeah.
Now, if object is in motion, let's have another case. We have this time we have this case where we're gonna have this spring which is connected to the mass m, and here we call it x equal to 0. That means this is going to be the distance is going to be 0, right? So the moment, the moment, uh, the moment, if it continues with the same speed, if it is not changing its speed, right? So that means That
Yeah.
means if it is, moving with a constant speed, so the acceleration is going to be 0 and the force is also going to be 0. But the V is going to be V maximum is equals to constant. Why?
Okay.
Because if the object is moving with the same constant speed, and that speed, if it is considered maximum speed, right? If it is considered as a maximum speed, by maximum constant speed, so the force and the acceleration would be 0, right?
Yeah.
Because if you consider the force is acting, if you think that the force is acting, so the body has to have the change in velocity, right?
Yes, sir.
Because changing the speed is one of the effects of the force. When you apply the force, the speed of the object changes, right? So
Yes,
therefore,
sir.
if I say the maximum speed is going to be constant, so the kinetic energy is going to be maximum. Why? Because if the speed is maximum, the kinetic energy is going to also be maximum, right?
Okay.
And your gravitational potential energy is going to be, sorry, the potential energy is going to be 0, right?
Yes, sir.
Now we have the case uh, where we are given with the pendulum. Okay, this is a point where the string is attached, and I'm going to draw different 5 lines, right? The dotted ones represent the different points, okay, at which the object is moving, right? And this line shows the equilibrium position of the object, right?
Yes, sir.
And similarly, on the right hand side, it will be here, and this is going to be your maximum, extreme point. Okay.
Okay.
Now we
Um,
gonna
sir, I'm sorry. Do you mind if you send this to me on the WhatsApp group?
I think I have shared all the working what we have been doing.
Yeah, but can you send this like this one as well?
Sure, why not? So the kinetic energy at this point, uh, the kinetic energy at this point will be 0 because the speed is 0. So at the extreme point, this is extreme point, right? Extreme
Yes, sir.
point, the speed becomes 0, so the kinetic energy would also be 0. So ultimately, your potential energy will be maximum. Clear?
Yeah.
Right?
Yes, sir.
And so the force that is exerting from the string, okay, is going to be constant, right? Clear?
Yes, sir. Yeah.
Right. So now at extreme point, since we have discussed that kinetic energy is 0, right? The
Yeah.
speed is
Yes,
0.
sir.
But the moment that it starts moving back, so it is going to be the extreme point, right? Because the object is approaching towards the mean point, right? Yeah. Or this is
Yes, sir.
you call a mean position. So here, when the object starts going back, the moment it starts going back, so it will be pulled. The object is going to be pulled with a greater force, right? The object is going to be going to be pulled with the greater force towards the mean position, or we call it reference point, right? Mean position
Yes, sir.
or reference point, right? So when we say that the maximum force is exerting now to pull it back towards the mean position, so ultimately we can also say that acceleration would also become maximum, right? The acceleration
Yes,
will
sir.
also become maximum, right? Clear? I hope this
Yeah.
concept is clear to you.
Yes, sir, it is.
Now, when it reaches at the mean position, what happens? When it reaches to the minimum position, so it uh let me just give me a second. All right. Now, when reaching to the minimum position, or sorry, mean position or reference point, okay, or equilibrium position, so the force is going to be minimum, right? The force is going to
Yes, sir.
be minimum, right? So
Yes, sir.
the force is going to be minimum, okay? And yeah, the speed is going to be maximum. Yeah,
Yes, sir.
the speed would become maximum. Therefore, kinetic energy would also become maximum. Clear?
Yes, sir.
Right? And the potential energy is going to be zero because it is just close to the ground and having the greatest speed. So all potential energy converts to the kinetic energy, right? And when we say that how this minimum force is exerting, um, because see, uh, at this point, at this point, at this point, where the downward force, um, I want to write in somewhere, but I do not have this space. Okay, so let me do it this way. Let me crop it, right? And let me move. So here, this guy for this, okay? Now,
Okay.
when we talk about, and you know that this point is the mean position, so let me remove this thing. I want to just show you that how the force is acting, right? The force, how the forces are acting. The one force, that is the weight, which is mg, and another force, which is the tension in the string, right? This is called tension
Yes,
in
sir.
the string. Clear? Now, are they in opposite direction, right? Yeah.
Yes.
But still the string is not getting close to the fixed point, okay, to the point P. The string is not getting towards the point P, and nor it is going away from the point P, right? So it is going to have the circular motion, right? Okay, it is going to have the circular motion, okay, type of the circular motion, right? Yeah.
Yeah.
And the acceleration that is acting, okay, on this object is going to be your centripetal acceleration, right? So we call, if you are asked to find out the acceleration at this point, you're going to use this formula v square upon r, right? So make sure that you memorize this one as well. We have already done this in the centripetal forces, right? Or
Yes,
work
sir.
done as well. So um V square upon R is going to be used when you are asked to find out the velocity, sorry, acceleration at this point, right? So due to which you are going to have acceleration, but it is going to be minimum, right? It is going to be minimum since the force is minimum here, as I have already told you, right? How this force
Yes,
is
sir.
minimum? Because at the same point, the two forces are acting, right? But some of the force will be there, will be acting, and then it will continue its motion and move to this point, to another extreme point, and repeats the same thing. At this point the kinetic energy would be max zero, the speed would also become zero, the potential energy would be maximum, and then it continues, it repeats this cycle, right? So I hope that you
Yes,
are
sir.
clear about this, how to find out what things are maximum, what things are minimum, right? So this is
Yes,
about
sir.
the max and mins, right? Clear?
Yes, sir.
Now we're gonna work on another question. It is about the graphs, right?
Okay.
So this question says that here is the waveform, and here we have the scale. Um, Time is given in seconds, and this on the y-axis we have the displacement, which is given in centimeter. So the waveform which is given, the one wave is completed till, okay, let me mark on the y-axis as well. So this here is 10, here should be 20, here should be 30, right? Now we're gonna have the another thing here. One cycle is completed, and another cycle is completed. Okay, -2, it goes there, and then it continues this to happen. Now we have the values. Here we have 2, 4 seconds, 6 seconds, 8 seconds, and that should be 10 as well. And there should be 12,
Okay.
right?
Yes, sir.
Now they are saying to find out the time period. So time period is what? Time period is what is time period? It is a time of one wave, right?
Measured.
The time taken by the one wave, right? The time
Okay.
taken, the
So
time
isn't time taken and time measured the same thing?
time measured by the same thing. What does this mean? The
No,
time taken
I
by.
I was asking, if time taken and time measured is like the same,
Oh, okay. You are saying the
isn't
time
it the same
measured.
thing?
Okay, fine. So the measure of the time by one wave. Okay.
Yeah.
You can say measure of time by one wave. Okay. Or the time
Okay.
taken by one wave.
Okay.
Right. So to complete one oscillation, the time taken by one oscillation, one wave, or one vibration, that's the same thing. Now you're gonna find
Okay.
out the time period. Uh, so time period means that one wave. How many seconds the one wave has taken to complete? One wave means one wave again. One wave means uh one wave means the one crest, or you call it peak, and one trough, right? One trough.
Okay.
So this part is known as peak or crest, and this part is known as the trough, right?
Yes, sir.
Okay. So uh, these two things are completed in how many seconds? In 8 seconds.
Yes, sir.
Yeah, are they
The
completed in
peaks.
8 seconds? One half cycle is completed at 4 and
And
half
yeah, and the other is completed at
another
8.
yeah. So another half is completed in 8 seconds. So the altogether one wave is completed in 8 seconds. So
Yes, sir.
one wave time equals to 8 seconds. Therefore, time period which is denoted by capital T is also 8 seconds. Clear? Right?
Okay.
Now,
Yeah.
if I ask you to find out the frequency, so frequency is if I have a time of one wave, so I am going to take 1 upon capital T, right? So 1, that is the number of wave that I have selected. So this is 1 and time period is 8. So therefore, I'm going to get how many seconds should be there? Yeah,
Um,
it should be 0.125, I think so.
yeah, 0.125.
0.125 hertz. Okay,
Yes, sir.
this is the unit of frequency, hertz, right?
Yes, sir.
Now, if I want to find out the time period, if I have a spring, if I have a spring, okay, and I want to find out the time period of the spring, right? The spring that is oscillating simple harmonic motion or performing simple harmonic motion. So how will you find out the time period of the spring? So uh, you will be using this formula, and in the last class we have already discussed this one, m upon k, 2 pi under root m upon k, where m is the mass attached and k is the spring constant,
Okay.
and where t is the time period.
Okay.
And another thing, how will you find this k? This k can be found out using the pulling or the pushing force, okay, F upon x, right? Where F is the force exerted, or you call it restoring force, and this is the distance covered from the mean position, okay?
Yes, sir.
Distance covered from the mean position. Clear? So I hope that you are getting these things clear, right?
Yes, I am. Yes, sir.
And if I have the pendulum, uh, which I discussed here, and I want to find out the time period, so the formula that I have to, applied is going to be T, uh, sorry, it's going to be T, um, 2 pi under root L over G, right? Where L is what? What is L? Hello, what is L? Length of the pendulum,
Hello?
and G is the strength of gravity.
Hello, sir.
Yeah, yeah. Okay, all right. I was asking about L and G. I have written that.
Okay. So, what is G?
It is written, if you can read, strength of gravity. That's going
Okay,
to be
and L is length
9.8.
of pen.
9.8.
Okay.
Now, what if you are asked to find out the uh, mm, the kinetic energy
So,
of
won't
the
we use the
spring?
same formula
Half mv square.
for kinetic energy?
Okay, and what if you want to find out
Yeah.
the gravitational potential energy or potential energy? So if I want to find out the potential energy in the in the system where we have the we have the, you know, what I was talking about. I was talking about the potential energy, right? Yeah.
The formula for potential energy.
Yeah. So the
Yeah. So
potential
the
energy.
formula is P is equal to mgh, right?
Oh, okay. MGH. So if you have a spring, if you have a spring,
Yeah.
so will you consider the height changes when the spring moves sideways? Is there any change of height? So how can you apply
Yeah.
MGH?
Yeah.
Mustafa, how can you say the spring is changing its height? It is written, it is moving sideways. How can you say that it is changing its height? My question, is it
Oh,
moving up
okay.
and down? Tell me. Or is it
No.
moving right and left?
Right and left.
Then will it change its height when moving to the right and left?
No.
Is this clear? So we
Yeah.
can't
So the
use
formula. So the
MGH.
formula is not him mgh, right?
We can't use MGH over there. This is what I'm saying. We can't use this
Okay.
MGH. Why? Because the edge has to be, from the surface of the ground, right?
Okay.
So this formula for the potential energy, we're gonna use half kx, okay? Half kx square.
Okay.
This is the potential energy formula for the spring. Okay. A spring attached, sorry, the mass attached to the spring performing simple harmonic motion, right?
Yes, sir.
Uh, Formula to calculate potential energy. Um, when the mass is attached and performing simple harmonic motion, SHM, simple harmonic motion, right?
Yes, sir.
Okay, clear?
Yeah.
Now, in the next class, we'll talk about the questions related to conservation of energy, right?
Okay.
Conservation of energy, and I think we'll be left with the adding mass to a moving spring, right? So, inshallah, we'll discuss that. Okay, so I'm ending the class here. We'll have class tomorrow as well.
Yeah. Inshallah.
Okay, Allah Hafiz. Assalamu alaikum.
Allah Hafiz.